In addition to the standard operations of adding, subtracting, multiplying, and dividing, when working with functions, there's actually another operation that we can supply, and that is composing two functions. Composing two functions is essentially just using one function as the input for the other function. So the formal definition says, given two functions f and g, the composite function denoted f composed with g, so it's read f composed with g, is defined by f composed with g of x is equal to f of g of x. So as you can see, we're using x as the input for g, and then we're using the entire output of the function g of x as the input for f. The domain of f composed with g is the set of all numbers x in the domain of g, such that g of x is in the domain of f. So in other words, when we plug x into g, we have to make sure that we get an output that we can then plug into f. And we'll talk about that a little bit more in one of our future examples. So let's start with one of the simplest ways to compose two functions, and that is composing them when we are given a numerical input for the first function. So let's suppose that we have f of x equals 2x squared minus 3, and g of x is equal to 4x. We want to find first f composed with g of 1. Well, remember that by definition, f composed with g of 1 simply means that we're going to take f of g of 1. So we're going to use 1 as the input for g, and then whatever we get out is what we're going to use as the input for f. So we start by coming over here to the side and finding g of 1, which in this case is simply going to be 4 times 1. G of x is 4x, so g of 1 would be 4 times 1, or 4. And so now 4 is the output of g of 1. It's what g of 1 is equal to. So 4 is going to be the input of f. So we find f of 4, and we do it the same way we've always evaluated a function. We plug 4 in everywhere there's an x, and then we simplify. So we have 2 times 4 squared. Well, 4 squared is 16. 16 times 2 is 32, and 32 minus 3 is 29. So f composed with g of 1 is going to be equal to 29. Let's look at another example. So in this example, we have g composed with f of 1. So in this case, notice that since g is listed first, the 1 is actually going to get plugged into, or we're going to evaluate f for 1, and then we're going to take that answer and plug it into g. So the order in which the functions are written dictates what we use as the input for each function. So by definition, g composed with f of 1 is going to be g of f of 1. So we come to the side, we find f of 1. So we plug 1 in for x. 1 squared is 1 times 2 is 2, and 2 minus 3 is negative 1. So f of 1 equals negative 1, so we're finding g of negative 1. So 4 times negative 1 is negative 4. So f composed with g of 1 was 29, but g composed with f of 1 is actually equal to negative 4. So I want you to see there that the order in which the functions are written can make a significant impact or have a significant difference on the output of the answer. So now what if we have f composed with f? Well, just like we can compose f and g together, we can also compose f with itself. So in this case, we would simply find f of f of negative 2. So we would start by using negative 2 as the input for f. So we're going to find f of negative 2. So that's 2 times negative 2 squared minus 3. Negative 2 squared would be a positive 4 times 2 would be 8. 8 minus 3 would be 5. So f of negative 2 is 5. So now we're trying to find f of 5. So f of 5, we plug 5 in for x. We get 5 squared is 25, times 2 is 50, minus 3 is 47. So f composed with f of 2, negative 2, is going to be equal to 47.